All right, so picture this. Instead of hard drives and cloud storage and all that jazz, we start storing our data in, wait for it, fractals.
Fractals?
Yeah, you know those crazy shapes like snowflakes, those infinitely intricate patterns?
Okay, yeah, I'm with you.
What if we could store data in those?
That sounds kind of wild, like something straight out of science fiction.
Right, but that's exactly what we're diving into today.
Seriously?
Yeah, we've got some Python code someone sent us. And get this, it simulates an AI that's learning to store data inside a fractal.
Wow. Okay, so we're talking about, like, actually building these things.
Well, not quite building yet, more like simulating, seeing if it's even possible.
Okay, that makes more sense. So how does it actually work? I mean, I get the basic idea of a fractal, all those repeating patterns, but how do you go from a cool shape to, like, storing actual information?
That's the million-dollar question, right? And that's where this deep dive gets really interesting.
All ears.
So it all boils down to this specific kind of fractal that the code simulates. It's called, get this, a 1N1 fractal.
A 1N1 fractal.
Yeah, a mouthful, right. But visually, imagine like a nautilus shell. Have you ever seen one of those up
Yeah,
close?
of course, those beautiful spirals.
Exactly. So picture those chambers spiraling outward, getting smaller with each rotation. Now imagine data points arranged in a similar way, spiraling out from a central point, and then, get this, smaller spirals branching off from each of those points, and so on, creating this insanely intricate, like multi-dimensional web.
Okay, I think I'm starting to get the picture. So instead of a flat hard drive, we're talking about a storage system with, like, almost infinite nooks and crannies. But how does the AI actually put data into those nooks?
That is the question. And the answer lies in something called data encoding.
Data encoding.
Yeah.
Okay, I'm familiar with the concept.
Right. So basically, the AI translates information into a format that can be stored within this super complex fractal structure. Think of it like creating a secret code where each bit of data is mapped to a specific point within the fractal. It's like assigning a unique address to each piece of information within this massive multidimensional space.
So each point on the fractal becomes like a tiny data storage unit.
You got it. But then how does it keep everything organized? It seems like it would be so easy to get lost in all those spirals.
Yeah, navigating that structure doesn't sound easy.
Exactly. And that, my friend, is where the AI's learning process comes into play. This is where the code gets seriously impressive.
Oh, this is the cool part. Let's hear it.
So the code simulates how the AI gets better and better over time at two things. First, finding the right data points within this crazy fractal, and second, actually interpreting the information that's stored there.
So it's like the AI is constantly building and refining a map of this incredibly complex landscape of data, kind of like learning the most efficient routes as it goes.
You've got it. Like having a superpowered GPS for data, but even better, it actually gets smarter the more it uses the map.
That's amazing.
Right, and get this, it gets even crazier. To make sure that no data gets lost, the code actually has the AI store each piece of information multiple times at different points within the fractal.
Multiple times. Wait, so it's like having backup copies in case one part of the fractal gets damaged?
Ding, ding, ding. You win the prize. Redundancy is the name of the game here, and it's one of the things that makes this fractal storage idea so intriguing. It's not just about the insane amount of data we could potentially store, but also about creating a system that's, like, insanely resilient.
Okay, this is blowing my mind. So we've got potentially massive amounts of storage plus built-in redundancy. This is getting good.
Okay, so we've got this AI weaving data into this crazy fractal, making copies, and it's learning how to find its way around this, like, unbelievably complex structure. But I gotta ask, what does this actually mean in the real world?
That's the million-dollar question, right?
Exactly.
What's so fascinating here is the sheer scale of storage we might be talking about.
Okay, so how much storage are we talking about?
It's hard to even fathom. The way these fractal patterns branch and repeat means you could, theoretically, cram an almost unimaginable amount of data into a relatively small space.
So instead of my phone constantly telling me I'm out of storage, we're talking about, like, shrinking down hard drives the size of, what, a postage stamp?
Potentially even smaller. Think about it. Current storage technologies, they're all about packing data onto flat surfaces. It's like trying to cram everyone onto a crowded train.
Been there.
Right. But with fractals, we're moving into 3 dimensions, maybe even more. Suddenly, it's like everyone has their own private compartment.
That's a much nicer train ride.
Right, you can fit exponentially more information in the same amount of space.
That's wild. And it's not just about having more storage space, is it? I mean, we were talking about potential advantages when it comes to speed and efficiency too, right?
Absolutely. Remember how we were saying that the AI stores the same data in multiple locations within the fractal?
Yeah, the redundancy thing.
Right, so if the AI needs to access a specific piece of information, it can choose the quickest and most efficient route to retrieve it from any one of its multiple addresses.
So it's like having a teleportation device for your data. No more searching through your entire hard drive to find that one file you need.
Exactly.
This is all starting to sound a little too good to be true. Are there any downsides here? Building these fractal structures, assuming we can even do that in the real world, seems like it would be incredibly complex and, I don't know, delicate or something. What about energy consumption? I mean, powering something like that.
You're right to be thinking about those things. Those are all critical questions. And to be honest, right now, we're in the very early stages of exploring this concept.
So, like, still in the lab.
Pretty much. This Python code, it gives us a glimpse into what might be possible. But translating that into a real working technology, well, that comes with its own set of hurdles.
What kind of hurdles?
Well, for starters, how do we actually create these crazy, intricate fractal structures, but at a scale that's small enough to be practical? And then, how do we make sure that the energy needed to encode, store, and retrieve that data doesn't outweigh all the potential benefits we've been talking about?
Okay, so are we just talking about a cool thought experiment here? No fractal flash drives anytime soon?
Well, I wouldn't go that far.
Yeah.
It's true, there are some serious challenges to figure out. But you have to remember, even the most groundbreaking technologies, they all started out as seemingly impossible ideas.
I guess that's true.
Take the first computers, for example. Those things were gigantic, took up entire rooms, and struggled to do even basic calculations. Now look at us. We carry more computing power in our pockets than those early pioneers could have ever even dreamed of. So, yeah, while there are still a ton of unknowns, I'm not ready to dismiss fractal storage as pure science fiction just yet.
I like your style. Never underestimate the power of human ingenuity.
Exactly. So even though we might not be handing out fractal flash drives as party favors anytime soon, what you're saying is that this deep dive, it's really opened our minds to a whole new dimension of data storage, right?
100%. And honestly, that's what I find so compelling about this kind of exploration, pushing the boundaries of what we think is possible and seeing what we can discover. You know, it's kind of wild to think that someday we might look back on our hard drives the same way we do those old floppy disks. Remember those?
Yeah, those are something else. Like ancient relics, almost.
Exactly. Museum pieces. But seriously, what you're describing with this fractal storage, it's not just like, oh, here's a slightly better hard drive. It's like a whole different way of thinking about data itself, isn't it?
You hit the nail on the head. It really is a paradigm shift.
So paint me a picture. What does a future with fractal storage actually look like? Like, if this actually happened, what would that world be like?
Okay, so imagine this. You walk into a building, right? But here's the thing. The building itself, the walls, the foundation, they're not just made of concrete and steel. They also store data. The way those bricks are arranged, the pattern of the wiring, it's all encoding information like the building's blueprints, its entire history.
Whoa, so we're talking about data not just being stored on things, but like embedded in them, an actual physical manifestation of data.
Exactly. Or picture this. You put on a shirt, but the fabric itself, the very fibers, are woven in a way that stores data, your entire digital life embedded right there in your clothes. No more need for external hard drives, no more cloud storage as we know it.
Wow, that's kind of blowing my mind here. So we're talking about a future where the line between the physical world and the digital world, it just kind of disappears. Data wouldn't just be something we access. It would be all around us, woven into like the very fabric of reality.
Exactly. And who knows, maybe this fractal approach could even help us unlock some of the secrets of, well, the universe itself. Think about how nature works. The incredible efficiency of DNA, how it stores all the information to build an entire organism, or those mind-blowing self-similar patterns you see everywhere in nature, from coastlines to mountain ranges.
Yeah, those are some pretty wild shapes.
Exactly, and those shapes, they're all based on fractals. So maybe, just maybe, by understanding fractals better, by figuring out how to harness their power for data storage, maybe we'll unlock even bigger secrets, find even deeper connections between, well, information and reality itself.
This whole deep dive has been one big mind-blowing revelation after another. Honestly, I have more questions now than I did when we started, but that's a good thing, right?
Absolutely. The best kind of learning always leads to more questions.
It's definitely sparked a sense of wonder and possibility in me, that's for sure. So, to everyone listening, keep those questions coming. The future of data storage might be closer than we think, and it could be a whole lot more fractal than we ever imagined. Thanks for joining us on this incredible journey into the world of, well, everything. Until next time, keep exploring, keep questioning, and keep diving deep.